Hello friends, good morning one and all of you, good morning. Here I am Gadekar Sachin Pandit. Yesterday we are discussed on solvent such as non-aqueous solvent. Okay, so in this we are discussed on their different types of non-aqueous solvent media, such as we are discussed on ammonia, sulfuric acid and boron trifluoride. Okay, ammonia, sulfuric acid and boron trifluoride acid, trifluoride, it is used in non-aqueous media. Okay, so boron trifluoride is a aprotic, highly polar. Okay, and this aprotic solvent we are used as a non-aqueous media. In this we are discuss there are three different types. Okay, first is the non-polar, second polar and third highly polar, in which we are discuss a first non-polar such as tetrachloromethane means chloroform, and benzene, cyclohexene, ionhexene, etc. This is the non-polar aprotic solvent. And then we are discuss a polar solvent such as DMSO, DMSO, acrylonitrile, etc. Formamide. And then we are today also discuss a phosphonyl chloride. Okay, they are also used as a highly polar self-ionized. Also it use a chlorinating agent and they highly polarize. So today we are discuss on hydrogen fluoride, then N2O4 dinitrogen tetroxide and ionic liquid such as pyridium, N-butyl, aluminum, tetrachloride such as ionic liquid, and then supercooled, supercritical and fluid. Okay, so today we are discuss on hydrogen fluoride used as a non-aqueous media, and then dinitrogen tetroxide, and then ionic liquid in non-aqueous media, and then supercritical fluid. Okay, so first of all, hydrogen fluoride. Okay, so you know the hydrogen fluoride is like water, highly polar in presence of hydrogen bonding. Okay, so it also self-ionize. Okay, so this hydrogen fluoride used as a non-aqueous media, but in this hydrogen fluoride solvent used at that time, we have to need a special apparatus like chemically inert in presence of HF. They are not react with this. Okay, so in our laboratory apparatus are made from silicate. Okay, so hydrogen fluoride reacts with this silicate, means glass containing materials is a silicate material. Okay, so silicate material reacts with hydrogen fluoride to forms a silicate compound. Okay, so that's why this we have to need a special apparatus, that is chemically inert, that is HF is not react with that apparatus. Okay, so hydrogen fluoride, liquid hydrogen fluoride. Okay, so in this liquid hydrogen fluoride is highly polar, highly ionized, and also used as a polar in nature. So it's use a ionizable. So it is use a non-aqueous solution and it is highly polar. So hydrogen fluoride self-ionize to forms it different behavior. So okay, first ionization process, HF ionize to forms a H2F plus HF2 minus. Okay, so this is the ionization process in which forms a acidic and basic. So this hydrogen fluoride media, non-aqueous media, self-ionize to produce a acidic and basic. Okay, so its behavior depends on a reaction. Okay, so it's behave as acid as well as base. Okay, so if it produce H2F plus, they act as a acid behavior. Okay, so if they are produce a HF2 minus, it behave as a base. Okay, so in this form a conjugate acid base pair. So these behaviors depends on a reactant. Okay, so many organic compound reacts with this hydrogen fluoride and they soluble in liquid hydrogen fluoride. Okay, so many organic compounds or amine compounds are soluble in liquid hydrogen fluoride. Okay, so this our body contain amino acids, so they react with this hydrogen fluoride and then itching. Okay, so burn our skin or damage. So this is the soluble organic compounds as well as amines. Like suppose acidic compound, carboxylic acid and amine are soluble in this. Okay, so example CH3COOH, carboxylic acid. Okay, acidic acid reacts with HF to forms a plus 2HF plus HF2 minus. Okay, so these types of bases are formed in this acidic acid protonate in presence of hydrogen fluoride and forms its ion. Okay, acidic behavior at that time. So next example, amine also reacts with this hydrogen fluoride and forms like this compound and in its protonate hydrogen fluoride. Okay, some protic acids like perchloric acid HClO4 or super fluorosulfuric acid. Okay, so in this acid behave as in liquid HF. Okay, so perchloric acids or fluorosulfuric acid reacts with hydrogen fluoride to forms its acidic behavior in liquid. Suppose HClO4 reacts with H2HF to forms a H2F plus Cl4 minus. Okay. So in this is the acidic in nature. So perchloric acid, it behave as acidic behavior in liquid HF. Similarly, fluorosulfuric acid HFSO F plus HF, it gives fluorosulfuric acid, it reacts with hydrogen fluoride to forms a SO3F minus plus H2F plus these bases. Okay, so fluorosulfuric acid reacts with hydrogen fluoride and behave as in liquid hydrogen fluoride. So similarly hydrogen fluoride reacts with stibine pentafluoride or tin fluoride to forms a super acid which is capable of promoting very weak base. Okay, so hydrogen fluoride forms a super acid which is capable to protonating very weak base. Like 2 hydrogen fluoride reacts with EsBF5 to forms a weak base like EsBF6 minus plus H2F plus. Okay, so in this hydrogen fluoride provides a acid protonate to this SbF5 to forms a super acid or magic acid. So this is the properties of hydrogen fluoride. So next is the N2O4, nitrogen dinitrogen tetraoxide. Okay, so it is also a highly ionizable as well as highly ionizable, highly polar, as well as its oxidizing agent. It's act as a oxidizing agent as well as nitrating agent. Okay, so this is the one more application of non-aqueous solvent in N2O4. It is a highly ionizable, self-ionization takes place, and highly polar, as well as it forms a nitrogen oxide and it's act as a oxidizing agent. Okay, so now we are discuss formation ionization process of this N2O4 ionized to forms a NO3 minus plus NO plus. Okay, so this N2O4 solvent, we are use a solvent to forms a ionized to forms NO plus and NO3 minus. Okay, so this is the ionization product of N2O4. So this N2O4 also act as a oxidizing agent. Okay, and this behave as a depends on the reactant. It behave sometimes acidic as well as basic. Okay, so this is the basic and this is the acidic. Its behavior depends on reactant. Okay, the example in reaction, it is good oxidizing and nitrating agent. Good oxidizing and nitrating agent. First example, so lithium, first group element, lithium reacts with N2O4 to forms a lithium nitrate plus NO. Okay, so in this reaction, lithium oxidize to forms a lithium nitrate compound. Okay, plus and minus. Okay, this will be reduced in this reaction. Okay, similarly other metals are used to forms a its salt, and this nitrogen, this NO is reduced. Okay, self reducing agent and oxidize for lithium oxide. So in this N2O4 encourage oxidation and reduce itself. Okay, so this in this reaction actually NO plus to converts a NO. So similarly it's encouraged to formation of oxidation. First, next example reaction, formation of tin chloride. First example of oxidation reaction to formation of tin chloride by using tin, SN plus Cl NO Cl NO in presence of liquid N2O4 to form a tin chloride plus NO. Okay, so this is the oxidation reaction. Tin oxidize and forms tin chloride. Okay, so this oxygen reduced to forms nitrogen oxide, NO. Similarly, copper oxidized to forms its complex like Cu reacts with 3N2O4 dinitrogen tetroxide to forms it complex like NO plus Cu NO3 thrice plus 2 NO. Okay, this NO is reduced and copper oxidized to forms it complex. Okay, so like this, these complex are formed. So this N2O4 is act as a reagent as well as solvent in this reaction. Okay, so this is the most important solvent as well as reagent in non-aqueous media. So next is the ionic liquid. What is the ionic liquid? It is the example of two salts combines to forms its liquid. So 2-pyridyl N-butyl in presence of, there are two types salts are used to formation of minus plus. Okay, so this is the example of ionic salt. Okay, so in this salt it is eutectic mixture of two substances. This ionic salt, it is a eutectic mixture of two ionic salt. First is the pyridyl N-butyl chloride and second is the aluminum trichloride. Okay, so these two salt mold in eutectic point to forms these types of ionic liquid. So this ionic liquid has sharp melting point lower than either of the component. Okay, first this pyridine compound, solid compound, and then this. After formation, this first pyridyl N-butyl chloride is a different melting point and aluminum trichloride is different point in solid state. After formation of formation of this ionic liquid, they sharp melting point either both types of solids. Okay, so eutectic behave as through it were a single substance like this. Okay, so first preparation methods of this ionic salt like pyridyl butyl chloride reacts with Al2Cl6 to forms a, this is the N-pyridyl butyl chloride salt, and another is aluminum hexachloride to forms these types of ionic liquid, pyridine, butyl chloride and air aluminum tetrachloride. Okay, minus. So this is the preparation method of pyridyl ionic liquid. So another examples of ionic liquid like this. This is the nitrogen plus okay, this is the another example of ionic liquid. So next is the similar like this. Okay, so this is the another example of ionic liquid, and this some ionic liquid used as a source of halide donor. Okay, so and they functionating reagent as well as solvent. Okay, so many applications of this ionic liquid use a non-aqueous solvent media. Okay, so this ionic liquid is utilized in various purposes. Okay, chemists use a reagent, biochemists use for a crystallization purpose, and separation technique, suppose gas chromatographically technique, at that time we use a supporting material, means stationary phase. So application of ionic liquid, application of ionic liquid, so many applications are available in literature. So first it use a solvent, non-aqueous liquid media, and biocatalyst also used for solvation, and then organic chemist use as a catalyst synthesis, biochemist also use, organic chemist also use for synthesis of catalyst, and these catalysts use in different way for formation of different types of reaction. So next is the application of separation, gas separation and extraction purpose, separation purpose and separation purpose in GC, gas separation. Second, heat storage, thermal fluid, heat storage, thermal fluid, and also use in electrostatic material analysis and crystallization process, lubricant, fuel additive, and electrolytic cell, fuel cell, sensor, and in battery. Okay, so this is the different applications of ionic liquid. So last point, supercritical fluid. Okay, so let me predict a diagram of supercritical fluid. So this is the pressure and temperature, pressure, temperature, phase diagram, one component, and this is the triple point of solid, liquid, vapor, solid, liquid and vapor. Here triple point of solid, liquid, and this point is the critical point. Okay, so in this phase, formation of gas, in this formation of vapor, and this formation of liquid, but in this point is a critical point, and above this critical point, increasing temperature, increasing pressure not forms a gas, but this forms a critical, supercritical fluid formation. Okay, fluid formation, not a gas formation. Okay, so in this above critical temperature and critical pressure, and compound is in its supercritical fluid state. Okay, so in this above gas and liquid phase to forms a supercritical fluid state. So in this Vapor pressure can be liquefied by increasing the pressure, but a gas cannot be formed. Okay, so in this supercritical fluid formation like H2, H2O, amine, NH3 and CO. Okay, so these liquid used as a supercritical fluid in particular temperature and pressure at that time forms a supercritical fluid, and this fluid used as a solvent in non-aqueous media. Okay, so out of this supercritical fluid of water, ammonia and carbon monoxide, out of this carbon monoxide is a clean alternative to organic solvents for a range of extraction process. Okay, out of this water, ammonia and carbon monoxide. Okay, so this supercritical fluid of carbon dioxide use a clean alternative to organic solvent for the range of extraction process. So example, supercritical fluid as in media for inorganic chemistry. Supercritical fluid used in inorganic chemistry. First example, conversion of metal nitrate to its oxide in organic. Just one of the examples. So many examples are given, but here we are explain only one. So formation of metal nitrate to its oxide. Suppose this is the metal nitrate reacts with supercritical fluid like H2 supercritical fluid. Okay, not a direct normal atmospheric pressure, but this use a supercritical fluid, and they first hydrolyze to forms a metal. Okay, so this is the depends on its oxidation. Okay, so forms a different hydroxide, and then this hydroxide converts to its metal oxide, MOH twice plus supercritical fluid of H2 to forms a metal oxide plus H2. In this process, first is hydrolysis takes place, and second is the dehydration. Hydrolysis takes place, and second dehydrolysis takes place to form its metal oxide. So many supercritical fluids are available in literature, but we are explaining here 3 types. Okay, so most of these carbon dioxide supercritical fluids is used in organic, and here we are explaining a formation of metal nitrate to metal oxide. Okay, first in hydrolysis process takes place, and second dehydration process. Okay, so in this chapter we are explain a different types of non-aqueous solvent media. Okay, different types of solvents are learned. So Thank you watching this video. Thank you. Have a nice day. Thank you one and all.